and then you will start sharing your screen.
Okay.
Okay, welcome everyone back from the short virtual coffee break. And as I said before, hopefully the next year it will be a real coffee break at the conference. It's my big pleasure really to introduce today's speakers, our first keynote speaker at this year's conference. The topic is Delineating the Scholarly Landscape of a Research Field. And the keynote speaker is actually the one which you suggested last year in the post-conference survey. So the last year we have one quite successful keynote speaker, keynote talk by Niels Jan van Eck, who spoke about the VOS Viewer and CiteNet Explorer. And then the people at the post-conference survey suggested Professor Chaomei Chen to be a next year keynote speaker. I suppose the people from the similar group, let's say, so people who are working also in the field of scientometrics and bibliometrics, because the Professor Chaomei Chen is a well-known creator of very popular software CiteSpace. So Professor Chaomei Chen is a professor of information science in the College of Computing and Informatics at Drexel University in the USA. He's the editor-in-chief of Information Visualization and the field chief editor of Frontiers in Research Metrics and Analytics. As I said, he's the creator of the widely used visual analytics software CiteSpace for visualizing and analyzing structural and temporal patterns in scientific literature. He's the author of the series of books on visualizing the evolution of scientific knowledge, as well as strategies and techniques for critical thinking, creativity, and discovery, including representing scientific knowledge, the role of uncertainty, the fitness of information, quantitative assessments of critical information, turning points, the nature of creativity, the information visualization, beyond the horizon, published by Springer, mapping scientific frontiers, the quest for knowledge visualization, and so on. So much more information about the Professor Chaomei Chen you can find at the personal webpage at the Drexel University. And today the professor is going to speak about delineating the scholarly landscape of research field. Now I'm going to go to give the floor to the Professor Chaomei Chen, because it's without sense for me just to read the abstract of his paper. He can do it much better than I to explain the main point of his talks. So Professor, the microphone is yours. I will stop sharing my screen and you can start.
Okay. Hello, everyone. My pleasure to be here with you. I'd like to share with you for the next hour. So the focus is on the research field. So I guess you can hear me. So
yes, we can hear you.
Yeah, great. So focus on the research field. It should be able to applicable to many disciplines, and so I will start with this the very basic concepts and some principles, and also theories that we should consider, and also at the end I'd like to offer some of my observations and recommendations. All right, so this is briefly the outline. I'll start with some challenges and go through this a variety of theories, relevant theories about how scientific knowledge change, and also how this underlying research community, what sort of patterns we can look for, or we should look for, and what can we learn from them, and how can we apply them to our everyday research activities. So this is a brief outline. We go next here. So very briefly, all the details you may be able to find in the these books. They explain more details, so I just mentioned very quickly here. And also, I'd like to draw your attention. We're creating a new section for this open access journal, especially on the research methods. So if you're interested in the early stage of this development, please get in touch. So I'll just leave this webpage here. So this is the, I would like to begin with this one, the quote here: "The eyes are not responsible when the mind does the seeing." So this is very intriguing as far as to my own research, my own understanding of what scientific research or research field is about, what is driven behind, and what can we see, what are the patterns. So this is something I would like to see. This is underlying what I'm going to talk about today. So first of all, the challenges in terms of the scientific literature, we're trying to do is, what we're trying to do is to understand scientific activity in all sorts of disciplines. But one of the challenges here, to begin with this one, is the scientific literature. This is what is it called, the paper mountain. This is 2014 in the Web of Science. There are about 58 million of scientific publications. There you see the mountain there. They take the first sheet of every publication, and that's a big mountain. But by now, today, the mountain probably about at least twice as high in the Web of Science alone. There are lots of other resources. Maybe we can talk about hundreds and thousands of millions of papers, publications. So this is the beginning of the challenge. An interesting observation there in this paper mountain is the most cited papers, they're actually only make a small part of the mountain. So the majority of those publications, they are never get cited, and then there are lots of issues there. So before I go further, I'd like to just like a quick reminder, refresher about some of the terminologies I'm going to use later in this presentation. So in particular, this is a record from the Web of Science. You might be familiar with it. If you're not, you're as a researcher, you know what these components are. So basically, we're going to focus on here. Let me get my, get a pointer here. So the references here is basically the previous work, the relevant work, related work that we cite, we reference for whatever reasons. There are a wide variety of motivations. People could cite or miss the citation they should cite, and so on. So here's the data we're working with at this point. There are lots of other levels. I'm going to mention some of them today, but these are the basic terms we're using. The citations or citation counts is how many times other papers refer to this paper. The pros and cons, and people using that as an indicator of many things, any kind of decision making. There are good things and bad things people have said about them. But here we're taking a neutral position to look at what can we learn from this local information to inform us about a broader context of what is the scientific activity and what is the scientific research field is developing. So this is the basic data or the terminology we're using. So some of the other kind of studies, like the co-word terms that occur together, and there are other concepts typically you found in the centrometrics, something called Co-Citation. So when you see the reference list, if they're listed together, they are co-cited. Most recently, the study or the granularity has been improved to study the within paragraphs, within sentences, the distance between them is getting much shorter. So in terms of proximity of those citations. So these are the terminologies. So one of the motivating factors here behind the way to look at the scientific literature is that in order to continue a research activity, you will need to know what has been done in the field, or what has been done, what has been addressed to the topic or the questions you're going to study. So here, one of the very influential one, I think, is the Hellmayer's questions. Basically, he recommended to ask these questions, series of questions, in order to clarify what you need to know, what is the questions here. In particular, we're going to focus on the second one today, is given a research question or research topic, what do we know? So we, in this case, collectively, that's all the scientific community has ever published, or even before they publish it, they're working on it, and so on. So that is the knowledge that is state of art. How do we get a hold of that? So this is a very brief sketch about the potential complexity that may involve at the everyday level. So suppose we're interested in the mRNA vaccines, and here we start from here. In Web of Science, we did, if we do a search, we'll find there are about 400 articles relevant to this particular search. That means basically the words either appear in the title, abstract, or keywords, and they are our starting point. So for this 434 papers, then you will think the more recent ones, we didn't search, there are about 4,000, over 4,000 articles that cite this set. So in other words, that implies these are potentially more recent progress, advances that make use of the same materials we are interested in. So going further from here, suppose we pick the highest cited one, the highest cited one here. And by that article itself, we can identify them immediately. That's that article cited like 200 papers. So this is actually a survey or review of the literature from 2018 at that point. So if we look how many papers actually cite this one, the most cited papers, now we have another way to bring in additional references or papers that we should read, we need to be aware of at least. So going further sideways, so we can ask the question, who else, what other papers have cited the same references? So that is the concept of bibliographic coupling, and we go that way. We go a step aside, we can see there are lots of more references that share that commonality. So that's one way to expand the scope of our search. So potentially you can look at here, starting with one article or one query, we're potentially looking at 23,000 articles that could be relevant in one way or the other. We don't know where to draw the boundary. So that is the challenge for how to delineate, how to draw, how to decide where we can make the cut, where's the boundary, the line, those articles are relevant enough, where all the articles we can probably put it in secondary, we can look at later when we get more time. So this is an issue that you can see that could happen in any research field, any discipline. But this is just one example of how can we go from here and using some computational methods to help or develop such understanding. So this is a quote from Bernal. He has been regarded as the father of science of science. He identified this in several decades ago. This is the scientific literature, the volume is so big, but we can only read a small part of them. But how can we know that what we're reading is the most valuable one? So how do we better spend our time on the understanding of this literature? And now today, the size of literature is growing even faster, and that problem can be bigger. And So there's some approaches that we can use. This is a one overview at probably the highest level. And looking at a scientific publication in this, what we call the dual map overlay. The dual map part refers to here. This is one map of scientific literature. This is the other map. So basically, when people publish here on the left-hand side, and that make references to the journal's publications, and that's located on the right-hand side. So we know that what's the source, what is the source of the influence, where they're coming from. So at this level, we know that you can tell by the concentrations of the disciplinary concentration that most disciplines basically build on their own previous history, previous results. So at this level, we want to go further down and we want to analyze what else can we tell from this. At this level, we see the probably the most stable stage in terms of discipline, how they shifted from each other, how they moving over time. But if we look at deeper at the probably more finer granularities, and then we can see other patterns. So one thing that is very commonly seen in many disciplines or different research topics, fields, is that the focus of the community, or so in terms of where people, the hot topics and where people pay their attention, that tend to move over time. So that means it's very unusual to expect that people can stay on the same research topic for a long time. Maybe some disciplines that seem to be slower than others, but generally speaking, we have seen these kind of patterns in many different areas. So basically, the red bars indicate the attention, the time of attention. So you can see this shift. This is the time. So this red bar is shifting from the left to the right. That means at different time, you would expect the focus maybe will be there for 5 years, 3 years at most, and depends on the field as well. So generally speaking, this is the dynamic or the dynamics of any research field. It needs to move forward or move to one direction or the other direction. We're going to talk about the theories about those. So this is the dynamics that we need to deal with when we need to understand what is a scientific field or research field is going to happen or it has been. So here's another view of scientific literature about this is information visualization. So we can see this kind of pattern quite common as well, is just the paths spread across the board. So starting from the left, you can see this, the year publication is about 2000, 2002, very earlier. And then here in the middle, you can see some publication 2005, 2007, and there's a more recent 2011. You can keep going this. So this is another very common appearance of this type of scientific field or research. They typically break up into components. So these components, sometimes they get focused, some other time they out of fashion, and sometimes they come back. So what could be the interesting features or the signals we can get from all these type of indications is again, this is a topic of lots of theories talking about. So this is one example that in between these different components or different continents, we can use this metaphorically intuitive terms. So one way is I'm going to mention some of the theories emphasize that the importance here it should be how we move, how the scientific community moves from one continent to another one, how they make the jump, or how long they stay. So there's some other theories about this, how long, what is the optimal time you should maximize the profits there when you're in a research field. So at least, for example, one of them is called the optimal foraging theory, and that's very influential, at least to my research as well. So there's some other observations we can make as the scientific literature moves forward. Sometimes events-driven some events, external events, driving the direction of the movement. So, for example, here this terrorism research, we can see here two significant jumps in terms of the new topics that are introduced into the domain, into the field. So let's talk about some of the theories we found is really inspiring, and more interesting, or more significantly, if we look at them side by side. And typically they don't make the same direct predictions. They emphasize different things, but it's very useful and very valuable, and to look at them, consider them all into our framework. So here the elephant and the blind man's and the elephant, that's a very good indicator of the situation. So we may think they look at different aspects of the same thing, but there seem to be more to that. So I'd just like to mention some of the most influential theories about scientific change, how science move forward. Here's Thomas Kuhn's very famous, very widely known structure of the scientific revolutions. There are lots of models of this are derived or from here. So typically, there's the concept of the normal science. From normal science, everybody know what they're doing, and then somehow there's a crisis, and that challenge the foundation of the normal science, the framework the normal science is built on. And then that leads to some alternative paradigms and competing paradigms that challenge the existing paradigms, and the revolution happens, and then we go back to normal science again, but at a different level. So this is one major influential theory that we consider for the past 20 years. So we'll look at this as a mind-changing or view-changing, but more a mind-changing principle. And so that echoes the quote I mentioned at the beginning: the eye is not responsible when the mind does the seeing. So mind, what do we think the scientific field should go? And that's what we expect. So that's the theory. That's the power of any theory, that we can inference from there and to expect what should be able to see if that theory is correct. So this is just one example. If, for example, in normal science, what do we expect to see in the scientific literature? If we're looking at the patterns, what sort of patterns should appear in the normal science? What can we tell if we're in a crisis stage? What else is telling us we're in a paradigm shift or already shifted? So another theory that I found is very inspirational is from the Schneider, this four-stage theory. This is maybe a very simplistic, but it's very intuitive, so that it also makes it very applicable to many different topics. So basically speaking, there are 4 stages for, you can consider this as a problem-solving process, but at the larger scale, at the community scale. So, for example, we consider the beginning of a field. To begin with, we need to have the idea. That's the first stage. It's called conceptualization. We need to be convinced enough to take this is a worthwhile problem to study. So that's the stage 1. And then at stage 2, people start to think about, we need to build some special tools to address this problem, to solve this problem. So without tools, that may be not possible. For example, we need a more powerful telescope to study some deep space phenomena. So after that, we build the tools, we apply to the original problem, and we may solve the problem. We may find we need something else, but that's the stage 3, typical stage 3. But then we could sidetrack from stage 3 is that here, once we get that powerful tool, and it's inevitable that we would like to apply that tool to something else, to something that we might have never looked at with this tool, because the tool was new. So that could be a very high chance to get some surprise and maybe the crisis that echoes Kuhn's crisis. That typically we found is if we're trying something new, we might find something that unexpected beyond our beliefs and so on. And so that is an interesting connection with the other theories. So stage 4 is codification. What works, what doesn't, so we know at that point. And also that it seemed to mark the beginning of the end of a field where we don't have any more motivations, and that's the time people should move on. And so this is, we take this as another framework to look at what are the possible patterns that scientific field may demonstrate. So here in one of the visualizations that may guide us, given this theory, we may look for some particular patterns. And for example, if we visualize them in this time parallel themes, so we can answer questions such as which one is really tool building? If the focus is really on building tools, does it mean we're looking at a stage 2 development of the field? And then we can certainly looking at the earliest one. Will that be the conceptualization stage? And the most recent one could be the application. If the application, we found lots of new terms, new terminologies, doesn't mean the applications exceeding the original scope is reaching something else, something new areas. So that would be a stage 3. So in this way, as you can see, we can apply this to our interpretation stage, or looking at scientific landscape, and to look at what are the probabilities of whether we should stay in a new field for how long and when, or who or which particular work triggered the jump from one field to another. So some relevant studies about the consensus, an interesting one here listed. The consensus seem to be, you can look at it in 2 ways. One is at the beginning, there's a lack of the consensus, and then the consensus increases. But if you look at this from another perspective, the consensus, once you reach consensus, and then maybe again we see the beginning of the end of a field, and that's in part there's some other theories to support that. So we may be looking at the possibilities from different perspectives. So the driving force behind the scientific field, one of them is the creativity, and also in particular here, one of sort of the creativity is the confrontations between different schools of thoughts. So this is in particular in Randall Collins' work. It's very inspiring as well. Here, he studied the great philosophers, and he found out the great philosophers, they are the ones that fight for their own schools of thought and to other schools of thoughts. So that seemed to be the characteristics of great philosophers. So here the lines, the red lines, indicate they have different opinions or different understanding of the things. So by doing so, they improve or they reach a level that other people may not. So here more very fascinating readings. I recommend you to take a look at this. These are philosophers, and these are how they're related to each other, and so that give us some hint of where we may be able to find the greatest thinkers. So there are some other theories from a sociological perspective to look at this scientific change. So I'll quickly move to here, some different criticisms about the revolutions, scientific revolutions theories. But here our point is to take all the theories together, and if we can create a computational tool and a device that can help us to better study this phenomena, then we'll be able to understand which theory provide us valuable information, which theory provide insights from different perspectives, and so on. So we're fully open-minded and to look at all the relevant theories and to study all the patterns the theories may recommend or anticipate. And so here we're looking at this as a general framework is that we can take all different theories and looking at them at the same platform and to see, well, what are they telling us? So we may learn a lot more than from learning from a single theory. So here's one example. When we're looking at a visualization of a network, this is like the invisible college and so on. So where do we start? Where should we pay attention to? So any theories behind that? So I need to speed up 15 minutes. And so here, one project from NSF is called Traces. That's telling us something very insightful is all the inventions at early stage, they don't talk to each other. Actually, that's a problem is that they don't know which one should be more profitable to talk to collaborate with. So that's the general simplification of that. They found lots of such cases, patterns. You see all these parallel lines coming down. There are few cross references in between until a very late stage. So that's saying that it's very important and to figure out the early signs, early indicators that we can benefit much earlier on. But it's a really fundamental challenge. How do we know that? So here's a quote from one study. It says, the difficulty is not always clear beforehand. So hindsight is easy. Beforehand, how do we know that what we're looking for, what could be very valuable, is located in the far side of a continent? So theory, this is called the structural hole theory, that give us some valuable direction. The red line here is called the structural hole or the bridge that in the less communicated area. So we're building on that theory to identify in terms of scientific literature, what does it mean if you found bridges like that? So for example, we have some indicators marked in purple, and these are supposed to be important here. They are linking the bridges, they're linking different continents. And so we're looking at this different indicators. Basically, they're showing something almost very unique here. This is one example that tell us the nature of that. So this is identified by one of those indicators and the locations. So it says this work particular established a connection that was previously thought to be incompatible. So that is a great revolutionary change. So this is the type of thing that we can hope we can look at this the structure of this kind of representation network and to look at what is valuable. So again, we're trying to identify what's in the huge big mountain that we should better spend our time to understand what is the bigger structure, big picture. So this is another example in this year. We can identify some of the positions here in this this is a measure of the something called a modularity of a network. We know that when the network has some shocks or changes, that something important probably was introduced in the system. So then that leads to our development of this structural variation. So the reminder, I have a 10 more minutes. And so this theory, that leads to this theory that we consider this as a complex adaptive system for this scientific knowledge. And all the time, all the publications, all the other news, the events are stories that makes potential impact to our beliefs, our understanding. So we may change dramatically when we hear something, we may not change what we think. So those are, we use that as a measure of the value of information. So the what we call the fitness of information. The most important one will be that could change our beliefs, change the way we think. So here's a quick example that in September 11, and here the paper here, what is the role of this particular paper? So before that publication of that paper, we believe that to get PTSD trauma, the people have to be on site and witness directly the trauma. And so their study, their contribution actually introduced something new. So if you look at videos, you could also induce the PTSD. So that is one example how knowledge is advanced. So we look at this, in particular, the bridges. We're looking at the missing bridges, or we'll look at backwards, and to see here in terms of continents, and so how people build their new bridges, and how many people follow their bridges. And so that's one way to look at the progress or advances of the scientific field. So here we're looking at a Nobel Prize study back 40 years ago. So that means before we know it's going to get Nobel Prize, what is in terms of the structure, what can we tell? Is there any sign or any early signs for that? So we know this is kind of bridges. That reminds us the theory, structural whole theory, that says must be something special here. So we're looking at this more samples, more Nobel Prize samples right now to see how generic this pattern can be found in different disciplines. So this is similar study. So all the dashed red lines here, they are the links between the continents, continental links. So those are, according to theory, this telling us that they are potentially important. So I'd like to, I think I have a few more minutes. I'd like to cover some of the topics about uncertainties. So uncertainty, you can see this is look across different perspectives. This uncertainty, you can see different sorts of uncertainties, but the most important one, what we call the epistemic uncertainty. That means we have contradictory information, conflicting understanding, the framework, the theoretical foundation, they are all incompatible. So those are the most serious conditions we have to deal with. And from the other point of view, from the sociological theories, that may be exactly the reason the people are motivated to study, because once they solve that controversial topic, and the reputation and what they get, what the stake is very high. It's higher than other consensus already established. So I will skip all these details, and this is using natural language analysis to identify the uncertainty. You can see some examples here. The mechanism is unknown. How does it work is unknown. So these are the sort of uncertainties. What is unknown? Another kind is different people believe different models or different things happening. So they need to have some reconciliation at some level. But this is what was really common in scientific literature. What is unclear, so that's in part motivate and to establish the meaning or the significance to do a new research topic. So these are all the details how to work at lowest level. Here are some examples. The red lines indicate the connections have never been there. And so naturally that will be our attention should be paid to those areas. And here this is a different level. This is something called semantic predications. This is like claims. And around those claims, you can see some other modifiers of those claims. Something unknown is unclear. And over the years, those things, some things change, some things still remain the same. But this is one way to better understand. It's hard to imagine a field without any uncertainty. So that's also in, and the other way to put it is that for a highly active research field, the uncertainty should be expected to be higher than others. And here are some finally more some examples to look at the field level patterns. So this is our early example about mass extinction. So the one here is one about 10 years pursuit of one theory, how this dinosaurs extinct 65 million years ago. And I found conclusive evidence there in about 90 early years. And then you can see this interesting movement. And so the community take this good example to move to another one to look at mass extinction 250 million years ago. So it's interesting. We found we published this work in 2006. Interesting. We found experts review summary in 2010. They almost drew the same conclusion as we did. But considering we are not domain experts, we're purely based on the cytometrics and these principles. And so I believe that's something that will be useful for domain experts as well as for the beginners to a domain. So this is another example. We're looking at the scientific literature. This is in a very selective way. So the suggestion is that we should only be able to focus on very small numbers, the small positions, special positions, instead of focus on all the center, everything. Those are established ones. Everybody should know. So here, this is in the paper. You can look at the detail. We interview the authors to ask them what's the role of their work. So this is a more recent example. This is about mRNA vaccinations. We start here in the early example. We start with the search, and this is most important paper identified there. Survey paper. So from there, we use a citation expansion, cascading citation expansion technique to spread out the coverage from the literature and give us generate this map, and to see that if you're starting from this one, what else you may be able to look at, you should be able to look at. And more interestingly, we see the references cited by this expert paper that we know. We also find it interesting to look at what kind of papers, what kind of positions they tend to be picked up by the experts. And so these are the ones actually recommended by the structural whole theory. They have a special characteristics here. They are at the one end or the other end of the bridges between different continents. So that this result is encouraging. So if you see those labels here, the articles, the blue labels here and here, they are not appear in the expert paper. Expert paper is actually here, but instead they share some structural properties that you might be able to extend your research. You look at something beyond this paper. The paper, the survey paper here, just give you a starting point. But if you go further, and this tool, this computational method, can help you to expand it. So again, so this is the figure I would like to probably stop here. And this is the way that we want to study scientific research field. And so that may be useful for us. Okay, so I think, yeah, I'm out of time here.
Yeah, thank you. Thank you very much, Chaomei, also for respecting the time slot allocated for your talk. And I noticed that you speed you up actually in one moment. So now it's time for the questions. I think it was quite inspirative talk actually by Chaomei. And there is one question here in Q&A. I would like to encourage also other people to raise the questions. So it's a question from Radwan Rana. Do scientific journal editors take into account results of your research and research of other scientists in development of research fields when considering acceptance of article manuscripts which might seem outside their usual scope or boundaries of the field they are related to? And I would say in this question, if not, why not? Because I'm not sure they take into account that actually.
Okay, that seems to be a complex question. Can you?
If you want, I can read it.
Chat window?
It's in Q&A box, so you should see the Q&A box. I can read it again, but the point is that, let's say, whether the editors of a journals take into account this research or some similar research because they are sometimes rejecting some papers which are outside of the scope or boundaries and not so ready for some new innovative papers and so on. I suppose it's somehow
okay. Yeah. So let me read this again. The scientific journal taking into account your research and research of other research. Okay, so I guess answer could be at different levels. One, certainly each journal has a scope. If you're submitting outside their scope, they will reject. But even some the borderlines, they see their audience probably not getting excited. This is a thing that people have discussed in the past. That as a journal editor, probably what they want is to showcase what was the thought-provoking and to make other people think and make other people do things differently. So everything else that could be happen all the time for all the journals, and that you can get accepted or get rejected. It's also based on reviewers and editors. But I guess this is the boundary thing, but depends on the journals, of course. I'm not sure that answered that question.
Yeah, of course, it depends on the journal and on the journal editors and so on. Yeah, and so my impression is that today bibliometrics is still related to to the publications and citings of publications and so on. But probably it's not the only measure today of the attention of some paper. Today we have the social networks, the blogs, some blog posts and so on, downloads, readings, and so on. So I'm not sure whether this, let's say, the field of bibliometric or science of science will be changed soon. It's not so easy process, of course.
Yeah,
but I want to say it's not the only measure to take into account publications and citation to see which is the trend of
right.
science.
Yeah, certainly, you're quite right. The my emphasize, my interest in this bibliometric data doesn't rule out any other sources. I found I can learn a lot about a scientific field, but that doesn't mean anything else I think is not so important. But there's a long-term debate that's from the science of science, or the region of science of science, is that research should be planned rather than spontaneously happen. Everybody go for their own interesting tracks or ways. But it is still a long ongoing debate. I don't think many people probably have different views on that. But the origin of that is once we can better understand the science of science, then we can make plans, strategic plans, so to better use all the resources and put the people's work on the most. That's idea from the social function of science from Bernal for example, for that. But on the other hand, all the Nobel Prizes, almost all of them, you look at them, almost none of them was really follow a pre-planned path to get there. So that's another argument. So again, that may take another hour to answer that question. But that's great.
I'm not sure that decision makers, sometimes are looking so deeply in the results of science. Somehow they are just expecting some numbers and then making decisions based on those numbers, which is not always correct.
Another good point. So in our open access journal, the Frontiers in Research Metrics and Analytics, so they are emphasized here is indicators alone will not work. So you, decision maker, this policy maker, you're not looking for an indicator that tell you what you should do. Instead, analytics that give you the story, the whole history, where it's coming from, where it may going. So those are the things you can't really replace it with the simple indicator of red lines, green lines, and that's too simple to begin with. So people have already emphasized that kind of danger if take indicators. Just think that's easy to compare.
Okay, and Chaomei, just one brief question because we are at the end of the session from the Peter Logan. To what extent might your research of knowledge change apply to non-science domains? Or do you think it's specific to science?
Oh, so I use the word scientific very broadly. I should probably use research. So that's the original. I research field rather than scientific field. I mean, to some people, the scientific people probably rule out some other disciplines, but to me, the scientific word is, just underline the scholarly rigor and anything that that's qualified as a scholarship. So that certainly include all the other research fields. So I want to make that clear. Scientific, it doesn't just mean the usual natural sciences. So.
Okay, Chaomei, then we are at the end of the sessions. Thank you very, very much for being our keynote speaker this year. As I said, you were actually a wish of our previous year attendees who specified that in our post-conference survey that they would like to see you as a keynote speakers. And thank you very much on behalf of them for being today with us. So we have now the 10 minutes break, or a little bit less than 10 minutes, and then we have another keynote speaker